Hi, I'm Neil from GroundX. In this video, our chief scientist, Ben Fletcher, will explain how our APIs turn complicated documents into text that LLMs can understand. Forms, tables, columns, extraneous text, even financial data, and many other types of content are easy for humans to read, but cause hallucinations with RAG applications if not handled properly. Fortunately, our APIs make all of that really simple, and Ben is going to show you how.
What I'm showing you here is a redacted copy of a transcript from the proceedings of a criminal trial. And this is the first page. The first thing that I want to point out are these numbers along the side rail. These are very helpful for a human to understand what line number on which page you're looking at. But for a technology such as OCR, it can be very problematic when you're turning this page into raw text. As you can see on the right here in the OCR version, the line numbers that are on the side rail are intermixed within the text. And this can cause all kinds of problems for an LLM and can even change the meaning of some of the sentences. If you look down at the bottom of this document, at the OCR version, the footer text has been combined with the last line of the transcript. But the fact that the OCR combines this text with the footer completely changes the meaning of the sentence. On page 3, there are references to the witnesses that speak in the trial, as well as the lawyers who examine them or cross-examine them. And this is basically the only reference to who the speakers are in the entire 300-page trial transcript. If we go to a random page in the trial transcript and we look at who's speaking, the only references are Q and A, where Q stands for question and A stands for answer. Let me show you an example from a query I made to Pinecone using the document that I just showed you. In the response from Pinecone, you can see this snippet of text that's returned, and it contains the line numbers intermixed within the sentence itself as well as at the beginning, and then the Q and the A, which gives me no information about who's speaking. So if you were to ask a question about what someone might have said within the transcript, it's very difficult to get an accurate answer to that kind of query when you just use a vector-based approach along with straight OCR text extraction. These are some of the problems GroundX solves for you. Let me show you the same snippet processed through the GroundX ingestion pipeline. As you can see, the Q and the A have been replaced with speaker names, and the line numbers that were randomly interspersed with the text have been completely removed and cleaned from the text. Here are results from a query to the GroundX APIs with the clean extracted text from the PDF, but also rich metadata that was automatically added during the ingestion to each snippet to maintain the context that is lost through standard text extraction processes. And we do this using a concept we call preprocessors. It's these concepts of cleaning text, adding metadata, and our own proprietary search that creates the improved performance over a vector-based approach.